Now this is question number 8. So we are given a body of mass 12 kg rests on a rough plane inclined at an angle of 30 degrees to the horizontal. The coefficient of friction between the body and the plane is 2/3. A force of magnitude P newtons acts on the body along the inclined plane. Find the value of P if the body is at the point of moving A down the plane and B up the plane. Those are the two conditions that we are to consider in solving this question. So I will pause in order to draw the diagram so as to save time. So after which we shall continue the solution to the question. So this is the diagram to the question. So since the question is of two parts, so this is for part A and while this one is for part B. So I drew two diagrams because so we are given two parts. So in the question. Now, so the angle of inclination now. So the plane, this is a rough plane, inclined at 30 degrees to the horizontal. This angle here, 30, is the same thing as this angle. Since the weight of the body will be acting vertically downward, this is the weight. So, and weight is said to be, so mass multiplied by the acceleration due to gravity, which is mg. Now, the same thing applies here. We have W, that is weight equals to mg. So, also here, weight equals to mass multiplied by acceleration due to gravity. Now, the component of the weight perpendicular to the plane. So using this angle is adjacent, that is, this side is adjacent to the angle. So adjacent is cos. So therefore we have adjacent over hypotenuse. We are using cos. Therefore this side here, so the vertical component of the weight, which is perpendicular to the plane, will now be weight, that is mg, then cos 30 degrees. So now the one that is parallel to the plane will be, because this angle is facing here, we have opposite, and opposite will be sine. So that is, the hypotenuse will now be mg, then sine 30 degrees. Here we have mg sine 30 degrees. So now in this case, so we are given that the condition number one that we are given, if the body is at the point of moving down the plane, what will happen? So don't forget we have a force of magnitude P Newton acts on the body. So if the body is at the point of moving down the plane, therefore the force P applied here, so will be acting in the direction of the motion of the force of the body rather. So the force applied will be acting in the direction of the motion of the body. So therefore, according to definition of friction is a force that opposes movement of two bodies whenever they come in contact. So when their surfaces come in contact, there is a force that resists or that opposes the motion, is said to be friction. So this body is at the point of moving down the plane, then the friction will oppose it. So the frictional force will be acting in the opposite direction. Then we have this to be frictional force, which will be acting in the opposite direction. And when we apply the Newton's second law, third law of motion, so that is action and reaction are equal and opposite. So therefore, addition of these two forces which are acting in the same direction equals to the frictional force. So that is, we have mg sine 30 degrees plus p, because they are acting in the same direction, because the body is at the point of moving down the plane, equals to the frictional force. And according to law of solid friction, so law of solid friction states that so the frictional force is directly proportional to the normal reaction. So that is F equals to moon R, where this moon is said to be the coefficient of friction. Also, we are going to apply the Newton's third law of motion, that is action and reaction are equal and opposite. So therefore, so the weight of the body, so that is the weight of the body here, which is, we are using the vertical, the one that is perpendicular to the plane, which is mg cos theta. So perpendicular to the plane equals to the reaction. That is Newton's third law of motion. So that is, we have R is said to be R equals to mg, then cos 30 degrees. That is, So the Newton third law of motion. So R equals to mg cos 30 degrees. So in place of R here, we are using mg cos 30 degrees there. Therefore, F becomes mg, that is F, which is moon R. So moon R, that is R is equal to mg, then cos 30 degrees. So we substituted the value of R here, or the expression of, in terms of the expression that represent R here, into this equation now. So therefore we have this. Back to this equation. So back to this equation, we have F to be this. We are going to substitute for F because we have to determine the value of P. So we have mg sine 30 degrees plus P equals to moon mg cos 30 degrees. So this question, we are going to solve this question without using calculator. So in the absence of calculator, which means we are going to leave our answer in short form. So this mg, we are given the mass of the body is 12 kilogram, and we have to take, so g is given to be, take g to be 10 meter per second square. 10 meter per second square. This is the value of g. So therefore we have 12 multiplied by 10, then sine 30 is 1 over 2 plus P equals to moon. So the coefficient of friction is given from the equation to be 2 over 3, the coefficient of friction between the body and the plane. So therefore moon, so we are given moon equals to 2 over 3. So therefore we have 2 over 3 multiplied by 12, then multiplied by 10, then cos 30 degrees equals to root 3 divided by 2. So this implies 2 goes in 10, we have 5. 5 by 12, that will be 60 plus P equals to 3 goes in 12, we have 4. 4 by 2, we have 8. 8 by 10, that will be 80. Then we have root 3 divided by 2. Then 2 goes here, we have 4. 2 goes in 10, we have 5. So therefore 5 by 8, that will be 40. We have 60 plus P equals to 8, then root 8 times 5. This will be 8. 8 by 5. 8 by 5, then root 3. So we have 8 multiplied by 5 root 3. So therefore, so we want to solve for P now. This will give us 40 root of 3. So P equals to 40 root 3, then minus 60 by collecting like terms. And by taking 60, so they are like terms, to the other side of the equation. So therefore, we have P equals to 10, or let's take 20 out. 20 into bracket 2 root 3 minus 3. So Newton. This is the value of P when the body is at the point of moving down the plane.